Well, good evening, everyone. I'm Paul Kern, Chairman of the Fire and Safety Division, and you're very welcome to Engineers Ireland. Tonight is our monthly round of CPD, and I'm very happy to welcome Gavin Young, who's the Director of Fire Eater here in Ireland. This evening's talk will be on the topic of gaseous fire extinguishing systems, which hopefully will be illuminating for all of us. I have no doubt that it will be. We would welcome questions. Please submit them using the Q&A function down at the bottom of your screen. Don't use the chat function. The talk will take approximately half an hour, and we'll then address the questions then. So, Gavin, I'll hand over to yourself, and you're very welcome. Thank you.
Thanks, Paul. Well, welcome everybody. This evening we're going to talk a little bit about gaseous fire extinguishing systems. So, I put together a brief agenda. I'm going to tell you a little bit about who Fire Eater is, what a clean agent system or fire extinguishing system is. Then we have a video on a clean agent system and how it operates. We'll discuss the different types of clean agents, both chemicals, which are halocarbons, and inert gases. We'll look at the primary differences between them. And then we'll look at a principle of operation of a fire suppression system. And we'll discuss a bit about our Inergen experience. And if we have time, we'll look at some case studies. So I am Gavin Young. I am a director of Fire Eater based in Naas, and I look after Fire Eater Ireland and Fire Eater UK, and I'm also the global business development for Fire Eater. Fire Eater, well, Fire Eater was established in 1974. It's a Danish company originally, but we operate across the globe in pretty much through distributorships and partnerships, through fire system integrators. We're 100% dedicated to fire protection solutions with Inergen. It's the only product we have, and that's all we do. We're known for our quality, innovation, safety, sustainable approach, and high level of service. So, clean agent systems, or gaseous fire suppression systems, or fire extinguishing systems, or gaseous extinguishing systems, they're all more or less the same thing. So it's a gas that goes into the extinguishing system. So a gaseous fire suppression system provides fast, reliable protection and are used for both the protection of sensitive electronic equipment such as computer, telecommunication facilities, data storage, archives, special risk areas such as hazardous substance storage, paint booths, foam manufacturing plants, hydraulic systems, printing presses, and turbines. The definition of a clean agent is a gaseous fire suppressant, which is electrically non-conducting and that does not leave a residue upon evaporation. This is ideal when protecting high-value items like historical artifacts or the likes of data centers with sensitive electronic equipment. The umbrella term clean agent covers a lot, both halocarbon and inert gas systems, but CO2 is another extinguishing agent which has similar properties, but is not generally called a clean agent because of the dangers associated with it. So I'm going to try and play this first video for you, which explains or shows you what a fire suppression system is.
Fire Eater. As the name suggests, we are focused on delivering the most optimal solution in fire protection. We all know that fire is devastating, not only as it occurs, but also where it may cause injury to people and damage to your production. After a fire, you may even suffer substantial downtime before your equipment gets back in shape again. At Fire Eater, we focus our business 100% on Inergen, a blend of air components found naturally in the atmosphere, 52% nitrogen, 40% argon, and 8% carbon dioxide. Inergen is an air blend that effectively extinguishes a fire and prevents it from spreading. It does so by lowering the level of oxygen below 15%. This way, the fire is extinguished and prevented from spreading. As with other fire extinguishing systems, Inergen is installed in cylinders under pressure and is released through nozzles when the fire is detected. After the release of Inergen, fire extinguished in less than 40 seconds. After extinguishing a fire with Inergen, you'll quickly be able to restart production, avoiding downtime. There is no danger to people, no damage to assets, and no harm to the environment. Inergen. No fire, no danger, no damage.
Okay.
Fire eater.
Okay. So there are two different camps, or two different types of fire suppression system. There is the inert gas systems, and they operate by reducing the O2 level within a protected area, thereby taking off one of the basically fire cannot sustain itself once you bring down the level of O2. It's a mix of natural gases that are occurring in the atmosphere. There are many, or 4 different types of gas. IG541, which is a mixture of 52% nitrogen, 40% argon, 8% CO2. There's also a common brand called IG55 argonite, which is 50% nitrogen and 50% argon. IG01 and IG100 are not used as much in Ireland, but they are present. Halocarbons then are a chemical gas. They're stored as a liquid, and they extinguish a fire by reacting with the fire and essentially reduce the temperature and bring the extinguish the fire by reducing the temperature. The chemical makeup of the gases are there in front of you. HFC 227EA, which is a common brand called FM200. Also, the most other common brand in the marketplace at the moment is FK5112, which is Novec. HFC 125 and HFC 23 are generally not used in Ireland. So just to talk about chemicals first, FM200 came out of the back of halon. When halon was banned back in 2003, FM200 was the replacement for halon. So it's a halocarbon gas, which falls under the F-gas regulation now under the Kyoto Protocol. It's considered to be a waste product, even though it's still in the marketplace. So since 2016, the global warming potential of FM200 became an issue. So it's been phased down. Essentially means being phased out, because it's not going in as a new product. It's only being replaced. So it discharges as a white gas. It's not environmentally friendly. So 1 kilogram of FM200 has the same global warming potential as 3 tons of CO2. When you have a fire, it decomposes into a form of hydrogen fluoride, which is corrosive and emits toxic gases. So it's not a very pleasant place to be when the system discharges when inside a room. Novec, or FK5112, which is the chemical makeup of Novec, it's a fluorinated ketone. Okay. It creates products of decomposition just like FM200. It's also a white gas. What you need to consider when you're looking at FM200 and Novec is if you've got a very large space like a data center, when the gas discharges, you won't see your hand in front of your face because it fogs up the entire space, so it would hinder escape. It requires both positive and negative pressure relief dampers. So each fire suppression system, be it an inert system or a chemical system, requires pressure relief dampers. because you're putting in a volume of gas into the room. There's an overpressure created. With Novec, it's both positive and pressure, so you need a two-way damper to relieve both types of pressure. It can create, again, hydrofluoric acid at a temperature of 900 degrees C, so it damages your sensitive equipment. It's a lot heavier than air, so in terms of a computer room, for example, that may be quite small, it will be very hard to get the room integrity for that. It's also known now as a forever chemical. So at the moment, just before Christmas, in December, there was a 3M announcement to make Novec that they're stopping the production of PFAS substances. So PFAS is basically a group of chemical products. It's everywhere. It's in the likes of Teflon. It's in makeup. It's also in FK5112. It's a polyfluorinated alkali substance. It's called a forever chemical. So it's being found in rainwater, in the ground, in meat, in chickens, and so on. So 3M, who is the manufacturer of Novec, has decided to stop production of Novec in 2025. So essentially, there's been a big shift in the market, because there was always chemicals with FM200. When FM200 was phased out, then Novec came along, and now that Novec is on the way to either going down the same route as FM200, and it's going to be phased out, or completely banned like previous chemical Halon. It seems that there is a massive shift away now across the globe against chemicals. So why Inergen? So Inergen is an alternative. It's an inert gas. As I said on the video, Inergen is 52% nitrogen, 40% argon, 8% CO2. It's in the atmosphere at the moment. You and I are breathing it in and out now. So Inergen ticks all the boxes in terms of environment. It will never have any issues. And it's safe for human beings to be inside a room when the Inergen is discharged. So how it works is basically it reduces the oxygen level. So it's at 20.9 or 21% oxygen now. So it reduces the oxygen level when it's discharged into an area between 14 to 10%. Thereby, fire can't be sustained. The name Inergen comes from inert gas and nitrogen. It's, as I said, it's got no environmental issues. It's non-toxic. It's fully tested on humans. We have done many thousands of live discharge tests, and it's proven for occupied spaces. When the Inergen system discharges, it doesn't damage any equipment. It's safe for human beings to be inside the room when it discharges. It's sustainable. There's no loss of revenue when it discharges, and it's proven for Class A, Class B, and Class C type fires. The primary differences between FK5112 Novec and Inergen then are, so on the left-hand side there you can see halocarbons, and on the right you can see inert, which is Inergen. Novec is stored as a liquefied gas. In Inergen is compressed gas. The design concentration is between 5.9 and 16% of Novec, and 40 to 51% for Inergen. So there's a lot more Inergen that's required when it's discharged into a risk or a room to discharge to extinguish a fire. There's a lot, which means there's a lot more cylinders and there's a lot more hardware. So there's a lot less hardware for Novik. There's storage pressure for the cylinders is between 25 and 42 bar. With Inergen, it's between 150 and 300 bar. So that means basically that your Novik cylinders need to be within 10 meters of your computer room or within the computer room, whereas Inergen systems can be located 100 to 200 meters away from the risk in a basement of a room of a building, for example. Novik and halocarbons all discharge. You have to get 95% of the gas into the room within 10 seconds. Whereas Inergen is discharged either 60 seconds for Class B type fire or 120 seconds for Class A. The discharge pressure is 42 bar at a nozzle and 60 bar at a nozzle for Inergen. The interesting one there is the maximum exposure time for FK5112 is 5 minutes. Now that's what's in the standards at present, but given that there is a restriction proposal coming from the likes of Denmark and France and Germany and so on to actually ban the Novik, I imagine that's going to go. The installation cost for a Novik system is the cost per kg of gas is high, as against the Inergen, which is low. But the cost for installation of the Novik system, given that it's close to the risk, is low, and the Inergen system, if you've got it 150 meters away, is a little bit higher. So I'm going to try and play this video now. It shows two different types of systems and how they discharge into a protected area.
Fire Eater ensures customized fire protection solutions of the highest quality. Inergen is a sustainable fire suppression solution exclusively consisting of natural elements from the air we breathe. 52% nitrogen, 40% argon and 8% CO2. A blend that extinguishes fire without consequential damage to the protected area, people or the environment. You can choose between two different systems, a single or a multi-zone system, depending on the area or object to be protected. The single system, also called a standalone system, protects one single room, whilst the multi-zone system, also called a directional valve or SV22 system, protects several zones at the same time, with a shared cylinder bank dimensioned to protect the largest zone in the protected area. The standalone system consists of a cylinder with a hand wheel valve, a discharge IV8 release valve with pressure gauge for monitoring, a solenoid with electrical activation, as well as hoses, manifold, nozzles and pressure relief dampers. In addition, the system has detection in the form of a smoke detector, control panel, alarm tableau and discharge call point. In the event of an alarm on one of the two detectors, the ventilation in the room ceases immediately, while the alarm is awaited from the second detector in the room. After the activation of the second detector, the system will start a preset countdown. Here, after the solenoid activates and discharges the Inergen system, the Inergen will be released from the IV8 discharge valve and will travel through the discharge hose up to the manifold. Activation of the remaining cylinders will occur through back pressure from the manifold. The Inergen is discharged through a network of pipework to provide a uniform concentration of Inergen throughout the risk. In addition to the components in standalone, the SV22 system consists of a series of zone valves and a SV-CIV starter kit. In the event of an alarm, The SV22 system's first actions follow the same procedure as the standalone system until the Inergen system is activated. Subsequently, the Inergen will be released from the IV8 discharge valve and will travel through the discharge hose. The Inergen will open the relevant SV22 zone valve by the SV CIV and 6mm stainless connected tube, and thereby open the correct zone SV valve. The Inergen is then discharged through a network of pipework to provide a uniform concentration Inergen where there is a fire. It typically takes 40 seconds to extinguish the fire. This is achieved by lowering the oxygen level in the room from 20.9% to between 10 to 14.2%. The Inergen concentration is held within the risk, leaving no chance of further reignition. When the extinguishing is completed, the operation can be resumed without unnecessary downtime and consequential damage to either inventory or the building. And most importantly, Inergen system is completely safe for people. After a fire, the standalone and the SV22 system can be easily restored as well, so that it is ready next time an incident could occur. Fire eater. No fire, no danger, no damage.
Early extinguishing efforts are essential. So basically what that means is the earlier you detect a fire, the better. So the earlier discharge into a risk when the fire hasn't taken hold, the better. So obviously you need a smoke detector to activate. It's done via what we call a double knock or coincidence type detection. So it's two different types of detector. Sometimes it's always an optical smoke detector and a multi-sensor. Used to be an ionization sensor. So you do two different types basically to pick up a different type of fire. Like if it's a wood fire, it'll be an optical sensor. If it's a smoldering electrical fire, it'll be an ionization type sensor. So there's two different types of detector. You have detector number one will activate and you get what's called a first stage alarm. It's basically an alert to warn people within the room to evacuate. And then when if a second detector activates, well then that second stage, it's fire confirmed and a countdown then is initiated. Generally it's around 30 seconds. Depending on the size of the risk, but generally it's about 30 seconds to discharge the they're all the same. Inergen and the halocarbons all use this type of principle. So when you're looking at a fire suppression system, you've got a computer room or an archive store or something like that you want to protect with the system. So you've got to determine well, what it is you're protecting. So there's two types of system. There's a total flooding system, which discharges into the room and you need a sealed enclosure. And then there's a local application type, which discharges, as you can see at the bottom, to around, for example, a printing press. So in Ireland, we operate to European standards, sometimes to American standards. We use EN 15004, Part 1 and 10 for Inergen. Part 1 describes the electrical and design concentrations that are required for discharging whichever type of gas that you've chosen for the risk. Generally, it's around 45.7% design concentration, so by volume. So what's important is the volume of your risk. So the amount of Inergen or inert gas or a halocarbon gas that is going to go into the risk is determined, and it's proportionate to the volume of the risk. So the larger the room, more gas you're going to need, because you need to keep your design concentration at 45.7. That then is held once it's discharged into the risk for a minimum of 10 minutes. All right. In terms of approvals, there are many approvals in front of you there now. These are all the approvals that the fire reader system have. You'll recognize maybe LPCB, UL, FM. The fire reader system has been, fire reader has been around since 1974. So we've one product since then, and we've developed it. So we like to think that the fire reader has the system itself has done the most approvals for any fire suppression system across the globe. So as you can see here, again, just to run through, it says it's a typical Inergen system, but to be honest, it's exactly the same way for any type of gas, be it chemical or argonite or Inergen or anything like that. So you have your risk, your room. You've got smoke detectors in the room and smoke detectors under the floor void. You also have your pipe network that goes into the room and under the floor void. You need to protect every zone or void within a given space. You have a control panel, your detection, your nozzles at the end of the your pipe work that give a uniform concentration. So they are calibrated. This is done through software that we have. It designs the size of the pipe work and the calibration of the nozzles. The pressure in the cylinders for our system is between 200 and 300 bar, depending on the risk. And you also need a pressure relief valve, which is a pressure relief damper. So generally, we focus on maybe two different levels of pressure relief in terms of structural strength. The risk it's either 200 pascals worth of pressure or 500 pascals of pressure that the structure can maintain. If you discharge the system into a risk without a pressure relief damper, the fear is that a wall will come down or a door would open and you won't hold the gas within the risk for the 10 minutes, and a fire could reignite. So the sequence of operation here is, so you've got a smoke detector is activated. It operates the panel. From the panel, then it generally shuts down, dampers, it sends a signal to a monitoring station, and so operates the fire alarm system within the building. When a second detector activates, it creates a second alarm on the panel and operates a pre-discharge. Then the time delay operates, and generally, as I said, it's 30 seconds. There's normally a hold button or an abort button at each exit to the room or the risk. Once you press that hold button, it starts the 30 seconds again. It goes back to 0 and starts the countdown again. This is to allow anybody in the room to get out. Once that countdown has elapsed, there's a signal. There's 24 volts goes down the solenoid circuit, activates the solenoid, and discharges the gas into the room. At that point, the pressure switch will give a gas gone or gas release signal back to the panel, and the gas basically then stays in the room for a minimum of 10 minutes. So it's important to look at the density and of the type of gas that you're looking at. Air, 1 cubic meter of air is 1.29 kilograms. You need to, as I said, have that gas within the room for 10 minutes. So you need to do what's called a room integrity test. And you have, you need enough gas for the highest point of your risk. So if it's a computer room, it's the top of a server, for example. So when you discharge the gas into the room is filled. You want that gas to stay in that room and not to what they call descend or descending interface, to drop. So from the highest point of your risk, which is the top of your server, the time it takes for the gas to drop from the ceiling within the room to the top of the server is the descending interface. And the longer that takes, the more retention you have. So the heavier the gas is, the faster the descending interface is, and the harder it is to hold the gas within the space. Generally, chemical gases are a lot heavier than Inergen or nitrogen or so on, and they're much harder to get retention. We do what we call full-scale testing. You can see the little oxygen meters on those people's fingers there. So we have a room out in Park West where we do live discharges. So we start a fire, discharge the gas into the room, and you can see the actual fire extinguished. But also you can stay within that room, and those monitors there monitor your oxygen in your blood level. And it just shows that you can be within the room when the system discharges. It's something that we use quite often, especially on projects that with a consultant, for example, we would bring them to show them that the system is, I suppose, the proof of the system. Areas of application. Well, the normal areas of application would be data centers or server rooms. Typically, that's where you would think, or switch rooms, for example. But more and more, it's changing. We do have a far reach in Ireland to the likes of the United States and the Middle East, and where water is a problem in the likes of Arizona, for example. So there's a lot of systems going in there into meat factories, office blocks. So it doesn't necessarily have to be the typical data center or server rooms. But so you can put an Inergen system into pretty much anywhere as long as you've got an enclosed space. An interesting one is in the likes of CT scanners in hospitals. We had an incident recently in Denmark where there was a fire and the sprinkler system activated, and it suppressed the fire, but it didn't extinguish the fire. Basically the fumes from the smoke of the fire got into the ventilation system, and they had 6 MRI scanners within this particular hospital, and the smoke went from one room to the other room to the other room, and basically, it damaged all the scanners within this hospital and created a huge amount of damage, and human damage as well, in terms of people not being able to get their scans and so on. So we've gone in and we've started to put in Inergen systems into those types of rooms within hospitals. Battery storage is also a massive issue at the moment. It's down to thermal runaway. Basically, once a battery ignites, you've all seen it. Once it goes, it's gone. So it's about early detection and the way the batteries are laid out within the space. So we also protect battery storage areas. I have some case studies that I can quickly run through with you and just give you an idea of some locations. This is actually the first project I've done, and I did back in 2013. It's a data center in Dublin. It was a pretty big one to put your teeth on, but so it's got 320 80-liter cylinders. There was 8 data halls on a directional valve system, so it's there's enough cylinders there to protect the largest risk. And it's a shared system, so if it protected, as I said, 8 data halls, but also I'm not too sure, but something like 10 switch rooms. And if a switch room activated, would take the required amount of cylinders from that cylinder bank and discharge the relevant amount within into the switch room. This is a project we did in Germany. Sprinklers wasn't an option because it was a laboratory. It had chemicals in it. Water would react with the chemicals, and what you didn't want is drainage. So what we did is we zoned particular rooms together and created a system for that. We have I think it's 64 systems going into the children's hospital. So yeah, we're protecting switch rooms and computer rooms in there. We're doing a lot of directional valve systems for that. Copenhagen is one of the largest systems. We're protecting the computer rooms and the server rooms and the air traffic control tower there. Another interesting one is cold stores. We've done quite a few cold stores in various different countries. It's probably something that's you know, it doesn't suit a sprinkler system given that it's so cold. So yeah, we're protecting cold stores. This is an old historic home in Denmark that we're protecting. Water again wasn't an option. It would damage the artwork and so on. So we put an Inergen system into that building. And last one is these are like Cardex units, like a robotic storage system, where we put systems into that too. So I am just going to finish up now and just say, you know, fire reader, it's no fire, no damage, no danger. It can be used in many applications, and it's fully sustainable. Thank you.
Thank you, Gavin. Much appreciated for all the effort you've gone to put that together for us. Some very interesting topics there, all right, and what you covered was very useful and informative. We've received a few questions in from the audience. I don't know if you can see them or not, but I'll go through them. Interesting one, is there an equivalent of a domestic system using the Inergen for kitchens, for example, in student halls or?
No, not for kitchens really. That would be more an Ansel foam system or something like that. No.
What about the planned maintenance on the systems?
Yeah, every 10 years you need to take the cylinders and hydrostatically test them. And then every 6 months it's normal maintenance like you would do on a fire alarm system, you know.
And tell me, the actual bottles themselves in the gas, have they got like a best use by date, or what's their storage period?
Yeah, so when you get them, they have a shelf life of 10 years, and then you basically have to go and get them hydrostatically tested. And once you do that, then they go back in for another 10 years.
All right. And you mentioned the smoke detectors in the room. Are they part of the building's smoke detection system, or are they actually particular to the Inergen themselves?
It can be both. It can be both. Generally, generally it's a standalone system with its own detection. Certainly within smaller systems, it would be like that, you know.
I was curious there about the historical building. Also talking earlier about the integrity of spaces or rooms. I'm just wondering how on earth you could allow for any kind of integrity in an old listed building, or
we have a system. So we would check out what the leakage is, because you need leakage. You know, there's obviously going to be a hell of a lot of natural leakage when the older the building is, you know, but you do need some amount of leakage. So we would quantify that, and if the leakage is too much, we do a thing called an extended discharge. So what we're doing then is it's not that you're extending, it's not like that you're feeding more Inergen in to top up. It's Inergen and oxygen and air. So a cylinder of Inergen and a cylinder of air, pure air, pressurized, together gives you about 12.5% oxygen. Okay, so you're feeding 12.5% oxygen into the room. It just basically stabilizes it at 12.5%. So you could just keep it going and going and going as long as you need. So you just work out what the leakage is, and then if you need it, then you top it up.
that could be continuous over the full 10 minutes?
Yeah, exactly.
Yeah.
Yeah.
Now, I've installed a few in the past, and I was always intrigued by the pressure relief valves and the almost like a weighted letterbox arrangement, little flaps.
Yeah,
very simple, very simple.
Yeah, yeah. Once it goes up to 80 pascals, they're fully open, and once pressure drops, they close.
Not your product, but one of our audience has asked about the Novec and the hydrofluoric acid being known as, or being called as a bone eater.
Okay.
Ring a bell?
Well, I know back in the day we did when I was younger and I didn't know about Novec, when we did some discharges and we had some glass, you know, just like a drinking glass, and the system discharge, and it was basically like it frosted the glass, you know, so it did affect the glass. So you know, so bone eater, yeah, maybe so in some way.
Yeah, quite a horrific description, to say the least. You mentioned that the bottles are storing gas under 300 psi. I'm just wondering, what's the discharge velocity at the actual nozzles, should I say?
It's 300 bar, not psi. So
bar, yeah.
Yeah. So there's two ways around that. There's what we call an open orifice plate, this calibrated plate, basically. So the 300 bar hits the plate and it goes down to about 100 bar directly after that. But by the time it gets to the actual room itself, it's about 60 bar at the nozzle. If you had your face next to the nozzle, that wouldn't be a good idea.
Yeah,
certainly not. But you know, it discharges. It's a loud bang. It's about 115 decibels when it discharges. So you know, it certainly would wake you up. But there's no harm in standing a meter away from it once it discharges. But you know, the other type is a constant flow type scenario where you're maintaining the same pressure over the 120 seconds of the discharge. So that it's still 300 bar to the regulator, the constant flow regulator. That'll keep it at, you know, 40-60 bar, and by the time it gets to the nozzle will be between 30 and 40 bar, something like that. You know, it still will make noise, but not as intense.
This question from myself, I'm curious, because when I worked in the Middle East, all of the approving authorities, they refused to allow the bottles to be stored within the protected zone. They always insisted it was actually, they were outside the room, down the corridor a bit. Any reason for that you're aware of?
it's like Germany. They want you to put cylinders into a cylinder room specific for just the cylinders. There's no particular reason for it. Normally, I think the low pressure Novik and FN200 either go modular within the room and are linked pneumatically or electrically, or just directly outside the room, and then Inergen is normally at the basement or 50 meters away or something like that.
In the cheaper seats.
Something like that, yeah.
One last question from one member of the audience. Will developments in the system replace the current 4 classes of fire extinguishers?
Fire extinguishers?
Hmm.
Don't think so. However, fire extinguishers are not my
Not your bag.
area. Yeah.
Great. Listen, Gavin, must appreciate it. Do thank you for your time again. And going to Dublin, join us this evening. Much appreciated. On behalf of the division and the audience, many thanks again.